actually going to delete Instagram. I can't lie, I don't see a need to have it. I'm going to open up Snapchat, but straight up, yeah, Snapchat literally has like... No one's added me on Snapchat in like 2 months. Yeah. Yeah, I seem to know all this, so hold on, is this? Metaphor, yeah.
Hello guys and welcome back to the channel. So today we're going to be covering some more interpreting information. So interpreting information has been quite highly requested over the last couple of days.
Yeah, we're going to look at Venn diagrams. Yeah, he only has 2, so it can't be that hard.
Hello guys and welcome back to the 5th section in decision making, which is Venn diagrams. Okay. So this has been one of the more highly requested videos, and obviously Venn diagrams, there's quite a lot to cover, so I probably won't be able to do it in one video, but there were a couple of important things that I wanted to go through in this video. I thought I would go through some of the questions and how I find best to answer them, and then maybe in a part 2 I will go over any remaining ones. Okay, so just a couple of things first of all. So with Venn diagrams, it's important to understand that you don't need any crazy level of knowledge. It's very much kind of an early high school, year 7 to 9 level of knowledge, probably just year 7 knowledge. Just a couple of things to understand. So obviously you've got unions and intersections. So intersections is when something belongs to both sets. So it belongs to A and B. And then union is if it belongs either in A or in B or in both. So covering everything. Okay? But once again, it's very, very simple concepts. In terms of what they actually get you to do in this section, there's 3 key ideas. You either have to draw a Venn diagram, you either have to read Venn diagrams and be able to interpret the information, or you either have to make Venn diagrams and then kind of see the Venn diagram that you've made, which one it's most closest to out of the answers. Okay, this will make more sense when I go to do some of the questions. Okay. But importantly, like I said, you kind of need practice with all 3. You can't just get over only being good at one skill. So you kind of have to practice a variety of these questions. And the thing with Venn diagrams is that there is just so many different styles of questions. But the questions aren't limitless, right? There's probably perhaps like 12 to 15 to 20 different styles of questions. But once you do enough of them, you should hopefully be getting good at this kind of idea of pattern recognition. Okay, this is important. So the idea is that as soon as you see it, you kind of know, okay, this is the technique that I have to employ. And with a lot of them, it will be obvious, because it will be like, oh, there's 2 towns, there's this many people that live in town A, there's this many people that live in both towns, there's this many people that live in town B, how many live in neither, or something like that. That's a more obvious one to find the answer to. Okay, so that's just simple pattern recognition. But there'll be others as well, like I said, that might be a little bit harder to immediately realize what you have to do. But the point is, if you do enough of these questions, if you do enough practice, you'll get to the point where it becomes instantaneous, where when you see the question, you know, okay, this is what I'm going to do, and this is what method I'm going to use. Okay? So the last thing I want to say is that Venn diagrams is one of those sections where you're not necessarily always looking for the answer. I know that sounds weird, but it'll make sense. So obviously with most questions, you try and like work it out. So in syllogisms, for example, they ask you the statements, you draw your diagram using the arrow method, you look at the statement, you try and work out what the answer is. But for some of the Venn diagram questions, for example, the ones where it says which of the following statements is true, it's kind of a bit luck based, because all you can do is, there's no way to find an answer, you just have to go through the options until you get to your answer. Okay, and that brings me on to my point, which is those luck-based Venn diagram questions, right? Because I call them luck-based, because if you're lucky, the answer's A. Because you read the first statement, you check if it's true, bingo, you've got your answer. But if you're unlucky, the answer might be D, because you might check A, realise it's wrong, go to B, check, realise it's wrong, go to C, realise it's wrong, go to D. Okay, and so for that reason, that's why I say that they're luck-based, because they're not about you finding the answer, it just depends on depends on the question entirely. And so me personally, I would rather prefer to do a question where I can actually hunt down the answer myself, if that makes sense. That's just a personal preference. So normally I tend to skip these questions. And what I'm going to do is, after I go through a couple of the questions right at the end of this video, I'm going to give you examples exactly of which questions I would do and which ones I would skip, and you'll be able to understand the idea of luck questions a little bit more in detail, if that makes sense. Okay. So just a couple of questions that I thought that were interesting to perhaps go through in terms of a walkthrough. So this is one of the first questions about Venn diagram. So it says, in Daleham, half of the 300 houses have both a front and a back garden, 100 houses don't have a back garden, 125 houses don't have a front garden. How many houses have neither? So one of the common ways in which this question gets done is people put front garden, back garden. Then obviously we know that 150 have both. And then here, people assign numbers. So they would say 100 houses don't have a back garden. So that's going to be x plus z equals 100, because that's the ones within that that are not within the back garden set. 125 houses don't have a front garden, so that's y plus z, because this is front garden, so not having a front garden is everything outside of that. That equals 125. And obviously we know this is out of 300, so all of these numbers added together, x plus y plus z plus 150 equals 300. We can simplify this, x plus y plus z equals 150, and remember, y plus z is 125, so you can just make that x plus 125 equals 150. So then x equals 25. And remember, we're looking for what z is, so then x plus z is 100, so z becomes 75. And bingo, you've got your answer. Okay, so this method seems clean, seems good enough. But the point is, actually, there's a faster way you can do this question, and this is how it will be. Okay, so if I just rub out this working for a second, and some of you may already know how to the fast way, but I thought it was something that's useful to share. So if I get rid of all these values here, and I go back to just 150 in the middle, okay, like this. So half of the 300 houses have both the front and the back. Okay, so look at the first statement. 100 houses don't have a back garden. So remember, we can flip the statement, because you either have a back garden or you don't, right? So if 100 houses don't have a back garden, that means 200 must have a back garden. So this must be equal to 200, so this must be 50. And if 125 houses don't have a front garden, then the remaining 175 must have a front garden. So this becomes 25. Okay, so how many houses have neither a front or a back garden? So that's just going to be the number on the outside. So we can add this up. That's 150 plus 50 is 200 plus 225, and 300 minus 225. So the answer is C. So you can see just a faster way of doing it. So it's kind of like two ways of doing it, but in this instance, you can kind of flip the question across. Okay, now it's only possible because this is kind of like a binary thing. You either have a back garden or you don't. Okay. So yeah, I thought that was an interesting question, interesting way to approach it. Okay, so let's go through to the next question. So this kind of question is.
There's no way that's actually on it. If I get a question like that, someone's getting nicked, man.
one of the more common ones. So perhaps if you guys would like to take a pause, see if you can have a go at this, perhaps. Okay. And actually, one trick here is that I actually don't use a Venn diagram for this question because I think it's easier using a slightly different method. Okay. So once again, I'll talk you through both methods. I'll show you how you can do it with the Venn diagram, and I'll show you how instead I would prefer to do it. Okay. So you can take a pause and let me know if you get the answer. Okay. So with this question, so first I want to talk you through the Venn diagram way, which I think is a little bit harder actually. And I'll talk you through the other way. So the difficulty with this question, when people try and do it with Venn diagrams, is they put down like adults and children, or they put down like males and females as the Venns. But with the Venns, you have to understand, Venn diagrams, like the individual Venns are binary. So what that means is, if you're in a Venn, you're that thing, and if you're outside, you're not. So you're either an adult or a child, or you're either a male or a female. So the point I'm trying to raise is, you don't need two Venns to display two pieces of information, you just need one. Okay. So if you put down adults and children, for example, there'll be no point, because obviously there's going to be no overlap between them. And you put down males and females, once again, there's no point, because there's going to be no overlap between them. Instead, what you have to do is you have to choose one from each side. So choose adults or children, and then males or females. So here it says 12 of the 16 adults are males. So I'm going to put males and adults as my two Venns. And we know 12 of the 16 adults are male, so that means there's 4 adults who are not male, so 4 goes there. And then we can put these two values as x and y. We know that this adds up to 27, so x plus 16 plus y equals 27, so x plus y equals 11. And we know there's 3 more males than females, so there's 3 more males than females. So males is x plus 12, females is everything outside of that, which is 4 plus y plus 3. So x plus 5 equals y. Okay, so I've just simplified that. So you've got two simultaneous equations as such. So I'm going to substitute the y in over here. So it becomes x plus 5 equals 11, 2x equals 6, and so x equals 3. So we've got our values. So how many male children are there? So that's going to be x, which is what we're looking for. So the answer is 3. Okay, but you can see we still had a little bit of work to do because we'd have to, because what we have to do is we'd have to figure out the equations and get simultaneous equations and then figure out the right numbers, etc., etc. But let me show you a different way, which I believe to be quicker. So it just involves a bunch of lines. So there's 27 people in a club that are either adults or children. The 3 more males and females. Obviously, we're going to have male adults, male children, female children. Okay, so it says, let's use the key ideas here. So 12 of the 16 adults are male. So we know the 16 adults are male, so therefore we know there must be 11 children, right? And we know 12 of the 16 adults are male, so this is 12, and so therefore this must be 4. What I like to do then is I like to put, there will be a line that will be something like this. So there are 3 more males and females. So I put a big plus 3 here. That tells me that overall we have to have 3 more males and females. Then I work out what the individual kind of like ratios are on each side. So here it's going to be plus 8. Okay, and remember we need it to be plus 3 overall. Okay, so that means that on this side it must be minus 5, so there must be 5 less males than females. So then what I do is I look for 2 numbers that add up to 11 but have a difference of 5. So let's start with 5 and 6, that adds up to 11, that's a difference of 1. 4 and 7 adds up to 11, has a difference of 3 though. 8 and 3 adds up to 11, has a difference of 5. So therefore 3 males, 8 females. And I find this way to just be faster. So how many male children are there? The answer is 3. Okay. So importantly, this tells us overall what these two numbers added up must equal, and then you just work out one side, figure out the missing number, and then it's just a little bit of trial and error. That's all it is. Okay. So this is the method that I definitely prefer.
Let me check the UK. Yeah, how many are there?
Okay. So if you guys would like to have a go at
Okay, so I got 21.
Question, and perhaps you can pause it, and then we'll go through afterwards. Okay, so with this question, this is once again a 3-Venn Venn diagram. Okay, so it says there's 150 in total. So with any kind of multi-Venn diagram, you always have to work from the inside out. So I'm going to read kind of almost backwards. So we know that there's yellow crabs, white dolphins, and starfish. Okay, so it says 7 had all 3, 9 had only starfish and yellow crabs, 12 had only white dolphins and yellow crabs, 20 had only starfish and white dolphins. And it says 81 had starfish. This is where you have to do a little bit of mental math. So this whole thing equals 81. Currently it equals 16, 20, 36. So this must be 45. White dolphins has to equal 43, so currently this all equals 19, 20, 39, so this must equal 4. 6 equals yellow crabs, this whole thing equals 60, so that's 12 plus 7, which is 19 plus 9, which is 28, so this equals 32. How many currents have none? You just have to work out the number on the outside. So the easiest way to do that, people think, is you just add all the numbers up, you subtract from 150. You can do that, but I want to show you a little trick you can do sometimes as well. So look at the endings of all of these numbers, okay? The endings are all different, okay? So what that allows us to do is it allows us to use a little bit of a math trick. So just bear with me a second while I explain. So we know that all the starfish here add up to 81, sorry, okay? So what we do is, we know it adds up to 81. We're just going to consider only the units then. So we're going to do 1 plus 2, which is 3, plus 2, which is 5, plus 4, which is 9. So we're basically doing 150, take away a number that ends in 9, so that number must end in 1, so it has to be B. Okay? Does that make sense? So you can only use this trick if all the ending digits, the units column, is different. Because if there's 2 numbers that end in 1, then we wouldn't be able to differentiate between them. Okay? So you can only use this trick at appropriate times. Like I said, also it's absolutely fine if you just plug in all these numbers in the calculator, but I think sometimes there's more likely to be like messing up a number or something. And this units trick is something that can be used, which is very, very beneficial and very, very quick and easy, I believe. Okay? Awesome. So on these last 2 questions. So one of the things I mentioned was about this idea of luck, right? So these kind of questions, I really, really dislike them because if I'm lucky, the answer is A. If I'm unlucky, the answer is D, right? It's just, I just have to go through the answer. Obviously, eventually you'll have to come around to doing them. So just a couple of tips and tricks, I guess. So one thing I'd say is you don't necessarily always have to do them A to D. Do the easiest ones, okay? So C, 15 people watch Neither Rovers or United. So neither Rovers or United is these guys. That's 19, so I know it's not C. Okay? The other thing is you can see there's a lot of stuff about watching City. So it's probably a good thing to work that out. So that's 20, that's 33 people who watch City. So more people watch City than did not watch. Unlucky, the answer is D, right? I just have to go through the answer. Obviously, eventually you'll have to come around to doing them. So just a couple of tips and tricks, I guess. So one thing I'd say is you don't necessarily always have to do them A to D. Do the easiest ones, okay? So C, 15 people watch Neither Rovers or United. So Neither Rovers or United is these guys. That's 19, so I know it's not C. Okay. The other thing is you can see there's a lot of stuff about watching City, so it's probably a good thing to work that out. So that's 20, that's 33 people who watch City. So more people watch City than did not watch. So this is did not watch City is going to be 14, 19, 21 plus 13. That's 34. So that's wrong. Now I'm going to do B over D because D looks quite long. B says few people watch City. So remember we've already got half of that bit. Then watch United. United is going to be 14 plus 5. And another thing to consider as well is since you're comparing between City and United, the overlap is going to be this. Like these two numbers are going to be the same for both. They're going to count to the total. So instead of just counting the total of City and the total of United, I can just count the total of those that are not within the overlap. You see what I mean? So for United that becomes 19, and for City that becomes 14. Okay, because obviously the bit in the middle is going to be common to both. So therefore B is going to be the correct answer. Okay, does that make sense? So the idea is obviously ideally I think we should skip these questions. We should come back to them. But even when you do go to do them, you don't necessarily have to do them in order. Pick the easy ones. And this is kind of a version of the last question, but on steroids, I guess, because this is a lot harder. And so once again, I would skip this one. But when I'm coming back to it, I would always do this question before doing this one, because you can just see it's way too hard. Okay, it's just long, and like I said, once again, if you're unlucky, the answer is D, and it's very easy to get tripped out, and very, very easy to get caught out in this. So personally, I'm not really a big fan of it at all. Okay, honestly, I'm not going to go through this question because it's just about just kind of almost manual labor in a sense. So you're just looking for words and just looking for correlations. So Centre A has 5 fewer employees on only social media 3. So I'm thinking circle, only rectangle. Then Centre B, which is pentagon, only rectangle. So I'm looking for circle with only rectangle being 5 less than pentagon and only rectangle, and then you just have to kind of search through. Okay, but instead what I'm going to do now is I'm going to take you through some questions to tell you which ones I would do and which ones I would skip. So I'm not necessarily actually going to do these questions, but in this video, but I'm just going to tell you, okay, this is one I would do, this is one I wouldn't do, and I'll explain my logic for both. Okay. Okay, so on to which questions I would do and which ones I would skip. So remember before, I'm going to explain what I mean about the luck-based study. So first of all, this is one of those, because these kind of questions, I haven't included the full question here, but what you have to do here, you just have to try and figure out which Venn diagram works. And so you have to say, okay, so this one, there's meant to be one of them has to add up to 20, for example, if 20 people take geography, or one of them has to add up to, sorry, 2 of them add up to 20 because there's 20 people take geography and 20 people take history. And in this case, you can see that that's not really the case, so therefore it wouldn't be A. And so you just have to keep ruling answers out, if that makes sense. And because of that, this is what I call luck-based, because you're not actively trying to find an answer. Okay, so I would skip this one. The next one, once again, is what I call luck-based, because all you can do is just read the first one, see if it's right, see if it's wrong. If it's wrong, you have to move on to the next one. If it's right, happy days, you've got your answer. But once again, it's not dependent on your actual ability to find and solve, if that makes sense. Like you're not actually looking for an answer. You're just trying to go through all the options until you finally reach the right answer. Okay. Similar thing once again. But another thing that I want to highlight is that there's orders of which ones I would skip. So all the others I would skip, but this is one I would skip this one too. I would do this one before the other ones because this one's going to be a little bit easier. Okay. Just because it's a lot shorter, there's less numbers, a lot easier to read. And once again, same again, too much effort to do. Okay, so I would skip this one as well. Okay, so in terms of the ones I would attempt, so this one you can see it is a Venn diagram. There's loads of stuff going on. But it says which of the following represents workers who get to work using a combination of car, train, and walking. So I'm looking for triangle, square, and circle. triangle, square, and circle. Oh, okay, I can see that's going to be out. So I'm working towards an answer, which is why I would attempt it. Okay. Once again here, which following best describes people in the region marked X? So this one I can just actively work out. So it's going to be star, circle, like a curved rectangle, but not regular rectangle. So it's going to be boat, train, bus, but not airplane. Okay. So that kind of idea. Once again, this is just a kind of a standard Venn diagram question. Grilled, scrambled, and fried, and then you just have to fill it in. Okay, so not only is it important to understand which ones are done, but also you kind of have to get to this point of pattern recognition where you see it and you think, I know exactly how to do that question. Okay, so that's really important too. And once again, another standard Venn diagram question. I would do this. How many customers bought cement towels? Once again, another standard Venn diagram question. Okay, how many cases containing red wine were delivered? Once again, I have to fill out the information for this one. This one's perhaps a little bit harder to do than one of the others, maybe, because the information seems a little bit more. As fluent. I mean, I haven't done it, but nonetheless, it's still one of the ones I would do before all of the ones I was talking about before the lock-based ones. Okay, so these are the actual ones I would prefer to do. Okay, and so that brings me to the end of this video talking about Venn diagrams, and I haven't covered a lot of the Venn diagram questions and how to do them, but perhaps I will do that in the upcoming video. Okay, so what I would like is, if once again, please do keep your suggestions coming in, if they're really, really helpful.
Okay, we're just gonna practice some. How many tunes are exactly 12 credits? So just 2 modules. Okay, so we got 14 plus 38 plus 32 plus 12. We got 96. 1/3 of the 8. Okay, so we have 18. 6 are vegetarian. Of these, 4 contain egg and 3 contain dairy. 2 of the dishes contain 2 contains both. How many vegetation is it? 4. Shit. One. Alright, the train at the station made the following stops: 35 stops in London, which 20 also stop in Reading. Okay, won't be this one. swear, bro, I had no clue what this one was talking about, G. I have to draw it. That's what I'm wondering. Was I meant to draw that, bro? All trains. Okay, so we got a vehicle here, yeah. Okay, all trains are vehicles, right? All trains have wheels. Okay. Some vehicles have wheels. Looks as if it had wheels. Not everything. Okay. I was just meant to draw that then. Okay. Yeah, we'll draw it next time. That was actually pretty easy. So, bruv, what? No one's gonna be all three, so it can't be that one. But there needs to be a mix, because it'll probably be this one. A local survey found. Okay, so we have 550. I reckon it's just 47. Numbers, you know, the upper. Yeah, bro. I'm sorry. Yeah, I'm not doing that question in an exam. There's no way I'm doing that in an exam. I'm like that guy. I'm skipping that. That's a dead question, G. This. This is also a dead question. This is an example the guy said to skip. I would skip this. This is a dead question. Actually, yeah. So I could have done 550. 550. Take away 42. Take away 323. It's 185. Yeah, I could have done that actually.
Hello guys, and welcome back to the fifth in decision making, which is Venn diagrams. Okay, so this has been one of the more highly requested videos, and obviously Venn diagrams is quite a lot to cover, so I probably won't be able to do it in one video, but there are a couple of important things I wanted to go through in this. Hello guys, and welcome back to the channel. So thank you all for all the continued support. I really, really do appreciate it, and if you haven't done so already, please do go and check out my SJT guide video, because what I've offered to do is I'm doing a giveaway. I'll be selecting one student to tutor over these next coming days, and all you have to do to be eligible is make sure you've liked the video, make sure you subscribe to the channel, that you comment on that particular video, and I'll be picking the winner sometime tomorrow or the day after. Okay, so yeah, just a quick little promo at the start. So I thought I'd continue with some more of the Venn diagram questions, because I didn't necessarily talk through every single style. I know I mentioned some of them, especially some of the ones to skip, but I didn't really talk about how I would do things. Obviously, hopefully you would still have the time to do. So let's just essentially get into it then. So let's have a look at what it says here. So which of the following letters represent workers who get to work using a combination of car, train, and walking? So I'm doing car, triangle, square, and circle. Triangle, square, circle, overlap. It's going to be L, so my answer is C. Okay, perfect. So that's question one done and dusted. Really nice question to do. Okay, so now on to the next question. This is one of those I would skip my first run through, but how would I actually do this? So which one of the following represents the activities taking place at the youth club that night? So I look for.
Okay, I think I would draw this actually. So A.
Immediately dive to look at the kind of like definitive ideas. So it says 6 people played no game, they just talked. So can't be B. And if I just go scroll down, okay, so ruled out B with that. It says 8 people played snooker. So it says 12 people, of which 4 also played snooker, played table tennis. So therefore, we need to look for one Venn that adds up to 8. So you can see in A, 4 plus 4 is 8. In B, there's no Venn that adds up to 8. So it can't be B, which we already figured out. And then, okay, D, that's fine as well, because there is technically a Venn that adds up to 8. But then it says 12 people, of which 4 also played snooker, played table tennis. So we need an overlap of 4, and then 4 on one side and 8 on the other side. So that works for A. It doesn't work for B, because then there's 16 people there. And it could work for D if all the people who played that sport also played another sport. But it says 9 people played darts, and none of which played snooker or table tennis. So it can't be D. We ruled out C because we didn't get something that added up to 12, and we ruled out B because we didn't get the 9, and so the answer is A. So you can really see why I dislike these questions, because the only way to do it is you have to take it step by step and rule out, as opposed to directly go and hunt for an answer. Okay? Okay, so let's have a look at this question. It says 40 people in the library, 24 mobile phones, 18 have laptops, 8 have neither. Based on the information, how many have both? So 40 in the middle, 8 have neither. So mobile phones, laptops, and it's asking for how many have both. So you can see in total we have 32 left to cover these three regions. And we know there's 24 with mobile phones and 8.
What you do, right? The 24 do not have mobile phones. How many have both? So 24 do not have mobile phones. You do 40, take the 24, 16. Okay, so 8 just have laptops. 18 have laptops. So 22 don't have laptops. 40 take away 22, take away 8. 10 just have mobile
Laptops. So that adds up to 42. And we only have 32 that's like available, essentially, if that makes sense. So that means because there's 42 people who like mobile phones and like laptops, so, but there's only 32 left in the Venn diagram, meaning there must be an overlap of 10. So the answer's got to be a 10. And if we put that into the middle, so 10 like have an overlap, so there's 14 here, and there's going to be 8 here. So that adds up to 18, 26, 40. So the fast way to do it is consider the difference between them. So the answer's going to be A. Here, and there's going to be 8 here, so that adds up to 18, 26, 40. So the fast way to do it is just consider the difference between them. So the answer is going to be A, 10. Okay, so based on the diagram, which statement is true by the individuals who have property insurance? So you can see property insurance is the arrow and it's within life. So they also have life insurance. Okay, I found my answer. So here, obviously, it was the first one, but I already considered that to be the answer based off on how the questions are done. Okay, so the point was I was looking for something specifically. Okay, so obviously, even if in this instance it was A, even if it was D, I would have been able to jump to the answer because it was fully within that group. So sometimes with these questions, although it might seem like it's a luck-based question, you can actually find it to some extent. Obviously, if that had been one of the options, then I would have had to just go through it manually, but here it was, so I'm just showing you that it's a possibility. Okay, awesome. Okay, so onto this question. So based on the diagram, which of the following statements is true? So let's play by the most. Okay, 17 people played all 4 games, so I'm just going to look for that overlap of all 4. I think that's only here, and that's 13, not 17. 39 people.
4, 23, 33. So blackjack.
Played only 1 game, so 10 plus 9 is 19, plus 4 is 23, and plus 90, that's wrong. So I'm trying to pick out easy ones. 3 people play blackjack and poker only. Blackjack and poker. I see 3 only there, and that's solitaire and poker, so it's not going to be that one, so I think it's going to be A. Okay, so once again, you can really see what I mean about like the luck idea. I guess here I probably should have had a look. You can see the triangle occupies most of it, but because I decided to do it this way, I went over to A, which necessarily wasn't the smartest because if I just done it sequentially from A to D, I would have got there faster. But once again, it goes to show the idea of luck versus actually trying to seek out an answer. Okay, so on to another one of the annoying questions. So it says, some people ask which flavors they like, particularly mint, blah, blah, and this sounded nice enough because we actually know what each one is. So everyone liked at least one flavor, so there's anything on the outside? No. The number of people who like curry only was half those who liked toffee and
Like at least one flavor. The number of people who like curry was only half the people who like both toffee. So, okay, so no, it's not A. No, it's not A.
both toffee and mint only. Okay, so curry only is going to be oval only, which is 4, and that's going to be half of those who like square and pentagon, so that's 8. So what's the first one? What's the second one? Doesn't work for the third one, so it's not C, doesn't work for D either. Okay, so next one. 5 people liked all 3. One works for the second one, doesn't work for the third one, so it's not. So curry only is going to be oval only, which is 4, and that's going to be half of those who like square and pentagon, so that's 8. So it works for the first one, works for the second one, doesn't work for the third one, so it's not C, doesn't work for D either. Okay.
Okay, I want to say curry equals oval, toffee equals square, mint equals pentagon. Okay, how many people who like curry flavor? Oval was half only. 7, 13, 17. B8, 14, 18. It's not B.
So next one, 5 people like
8, 14, 20. It's not C either.
D either. Okay,
No, it is D.
doesn't work for the third one, so it's not C.
8, 14. What? What have I done wrong? Like curry, which is an oval. Oh, curry only. Oh my days, I'm such a numpty. Well, I already got rid of A. Curry only is 4. Well, it can't be A. 4 could be B. Can be B.
Square and pentagon, so that's 8. So it works for the first one, works for the
6 doesn't work for C.
second one, doesn't work for the third one, so it's not C.
I can already get rid of this B.
Doesn't work for D either. Okay, so next one, 5 people liked all 3 flavors, so it's got to be B. Okay, actually this one was a little bit nicer than we thought, but there have definitely been other ones that are a bit longer. So actually this one seemed bad, but I guess it wasn't too bad to do in the end. Okay, but once again, I guess it's kind of luck of the draw, which is why I tend to like to steer away from them. But you know, I'm not going to say that they're all bad. There may be some good ones in there, but once again, just depends on how you are normally with them. I think this one's a little bit nicer because they've told us what it is definitively, like curry is oval, toffee is square. But sometimes they don't do that. Sometimes they just leave it ambiguous, which definitely makes it a lot harder. Okay, so one last Venn diagram.
No student been to the theatre and the museum. Oh, no students been to the theatre. This is at 20. 9 students have been just to the museum. 7 students have been just to the cinema. How many more students have visited to the museum? Is it? Oh, okay. Museum had 39. We do 39, 46, that's 4. And the theatre's 24, 15. B, boom, done.
One question to finish off on that. So we've got it's a 3 Venn diagram. So cinema, theatre, museum, cinema, theatre, museum. 50 people in total. 50 students had made at least, all students had made at least one visit. No student had been to the theatre or the cinema. 10 had been to the cinema and museum. Twice as many had been to the theatre and museum. 9 had been just to the museum. 7 had been just to the cinema. So 7 plus 10 plus 10 plus 20 is 30, plus 7 is 37, plus 9 is 46, 4 in here. How many more had made a visit to the museum than to the theatre? So here, the bit in the middle is common to both, so I'm kind of going to ignore it. So now it's just a comparison of 19 and 4. So I could add up the 20 on both, but like it's not going to play a part. So 19 minus 4, the answer is 15. Okay, so I hope that made sense. It's a little bit more of a shorter video, but it's just a follow-up on some more of the Venn diagram questions. Hello everyone and welcome back to the last section of decision making. So I released a decision making mock in my last video, and so this is the very last video I have to do. just finishing off decision making essentially. Obviously, I will release some more follow-up videos just on each of the sections, just answering some more of the questions, talking through some more of them. But please let me know what else you would like to see in regards to content. Obviously, I have more QR and then VR and SJT content coming up as well. But importantly,
So she actually only got 675 on average, which actually no, I can't even say she only did. That's pretty much all of my score.
it's really useful for me if I can get feedback from you guys as to what you're looking for exactly. Okay, so a couple of important ideas of probabilistic and statistical reasoning, or probability as everyone calls it. So the first thing is that the questions that come up repeat very much. Okay, so there's probably maybe like 10 to 12 different styles of questions, I would say. Just, it's just a rough number off the top of my head, but they repeat and they come up so many times that if you do enough practice with this, you'll know exactly how to answer each question as soon as you kind of see it. There's one style which I would say comes up way more than the others, which is the judging based only on, and then it gives you two variables, is X better than Y, for example. And I'll tell you how I would do that one exactly. But other than that, all the other variables all the other questions come up fairly equally, and so therefore it's just about trying to get through as many of them as possible. And getting to that stage, where we said, it's just about pattern recognition, just about as soon as you see it, you know exactly what to do. Okay, so some of the key ideas with probability. So first of all, the probability of something happening plus the probability of something not happening is 1. Okay, so the probability of something happening plus the probability of it not be happening. Again, if those are two individual events, that's the probability of A multiplied by the probability of B. Okay, so just some basic ideas. Like, the probability questions really aren't too difficult at all. It's just about kind of understanding the different styles that comes up. That's all it really is. Okay, so in terms of how to go about doing it, so the way that I would always say to do it is work out the individual probability. Okay, so always look at the question, try and work out the probability, and then ask yourself the question, and you'll often be able to find the answer. It'll make more sense in the examples and walkthroughs that I'm about to show you today. Okay, so in terms of kind of the techniques that I use, I would say probability trees. Okay, so it's important to be able to understand how they work, and perhaps not in this video, but in one of the later videos I will do a question on probability trees. And if you guys would like to see that, please do comment down below. Just remind me. Tables. So I'll explain what I mean by tables. I'll show you like the table method that I use in order to work out those judging based only on X or Y questions. And then finally, the different methods as well. It's important to understand, okay, so how do I do this question? How do I do this question? And that's why I decided to take you through some extra examples in this video as well. Okay, so without further ado, then I think we should just get straight into it. So this is the style of question I mean when it says, only likelihood of all, or judging based only on, and then it gives you some variables and it gives you a question. So what I like to do is, if you make a table, and you need to put exactly as it says here. So the coach's team scoring a goal and the opponent team not scoring. Then you have the two things to consider, which is player A and player B. Okay, so it tells us, so if you think about it, obviously we want the coach's team to score, and we also want the opponent team not to score. So we want both these values to be as high as possible. That's not necessarily always the case. It might be sometimes you want one to be as high and the other one to be as low. So for example, if it was, you've probably seen this kind of question where it gives you, there's a disease, there's two treatments for it, this produces this cure rate and it has this side effect rate. Obviously you want the cure rate to be as high as possible, but you want the side effect to be as low as possible. Okay, so let's start. So football coach wants to replace a player in the second half of a match. If player A is replaced, there's an 80% chance of the coach's team scoring. So I always like to use decimals, and 70% chance of the opponent team scoring. So that's a 30% chance of the opponent team not scoring. If player B is replaced, there'll be a 20% chance of the coach's team not scoring. So that's an 80% chance of the coach's team scoring, and a 50% chance of the opponent team not scoring. So you can see coach scoring is going to not be relevant here. Okay, that's not going to have an effect. So is player A the best replacement choice? When we want the probability to be as high as possible. I would look at my diagram, my table, and I would say no, I want player B. So I'd say no, so that rules out A and B. And then let's look at C and D. So D talk says there's a low chance of the coach's team scoring. We know that the answer has nothing to do with the coach's team scoring, so therefore it has to be C, and C makes sense. Okay, so obviously you don't necessarily always have to do the table. I've kind of got to the point where sometimes I do the table. You'll see my DM walkthrough that for some questions I did do the table, but you don't necessarily need to. If you're able to, when you read it, one of the kind of key tips I would say is look out for opposing numbers. You're not just looking for the numbers that are the same, but like 80 and 20, that adds up to 100. So therefore it's likely that one of them is going to be on the other side, if that makes sense. So for example, it said 80% is the coach's team scoring, and the 20% is the coach's team not scoring. That kind of idea. So don't just look for the exact same number, look for opposing numbers as well. Okay, and so yeah, and another thing to talk about here as well, which is important, is that normally an answer won't be contradictory. So what I mean by that, it's not like A is going to have greater coach scoring and B is going to have greater opponent team not scoring. Does that make sense? It's not like A wins one, B wins one. It's either one person will win both, so they'll either have greater coach scoring and greater opponent scoring. B already has one. Tip or trick, I guess, as such. Okay, so let's move on to the next. So, considering only the likelihood of rain and the pool remaining closed for maintenance, should Harry buy the outdoor pool pass? So you've got, if you read to the top, it says you buy something to pass to an outdoor pool or an indoor pool. The outdoor pool remains closed when it rains. Past records indicate there's a 0.3 chance it will not rain, so the chance of rain is going to be 0.7. See, it doesn't tell you this explicitly, but the rain is going to affect the indoor pool. That's why it's not mentioned in the rest of the question. And here you can see, as I'm reading, it says the likelihood of the pool remaining closed for maintenance is 3/8 for the outdoor pool and 1/6 for the indoor pool. I can see those are both equivalent fractions, so I don't even need to fill that in because I know maintenance can't have an effect on my answer, if that makes sense. So therefore, I'm going to rule out D immediately, and therefore I know the only thing I need to consider.
Bruh. I thought I said 3/8.
The rain here. And remember, we don't want it to rain because we don't want it to close. And so therefore, I would say, should Harry buy the outdoor pool pass? Remember what I said, ask yourself the question. No, he should buy the indoor pool pass. So since it's no, the only answer possible is C. Okay, so remember, always ask yourself the question, and we'll try to answer them and eliminate our answers. Okay, cool. So this is what I believe to be the most common style of question. These are the ones that always comes up, and you can do these really, really fast. And if you go back, if you guys are new to the channel here, if you go back, I just did a decision-making walkthrough, where I kind of went through a mock together, and you can see these are the questions I really like to do because I think you can do them really, really fast. Okay, cool. So let's have a this one. So the person who selects game one has the best chance of winning. So game one, roll with dice, and you win if they both show even numbers. Roll with dice, and you win if they both show odd numbers. So game one, even numbers is 1, 2, 3, 4. So remember, for both dice to show even numbers, it's the probability of each one multiplied together. So it's 4, 6 even on the first one, 2, 6 on the second one. So that's 8 out of 36. On game two, they both show odd numbers. Odd numbers is 1, 2. So 2 out of 6, and it's going to be 4 out of 6 because numbers are either odd or even. You can see two of them are even here, so 4 must be odd here. So you can see equal chances. First thing that's game one has a better chance of winning. I'd say no, and you can see C is going to be the correct answer here. Okay, so remember, always do the probability, do the maths. I think sometimes the difficulty students have is trying just like that initial step of just starting to do the maths. Okay, it can be quite challenging, quite daunting because you might not necessarily know where to go, but you can only work with the information that you have quite literally in front of you. So never forget that, and then just kind of like take it from there essentially, if that makes sense. Cool. Okay, so that's pretty much the kind of main idea with a lot of these. Remember, always ask yourself the statement. Okay, so on to the last question. So Diana has a box containing 6 pairs of earrings that are
It's A.
identical in every way except color. There are 3 red pairs and there are 3 blue pairs. Each pair contains 2 earrings of the same color. Diana wants to draw a number of earrings at random such that she has at least 1 complete red pair and 1 complete blue pair. Should she draw 8 earrings randomly? So the way to do this question is to consider the worst possible case scenario. So what I mean by that is, so if you've got these 6 pair of these earrings, it could be that she draws out all of one color pair, so she draws out all the blues, all the reds, and then that would leave her with just the other color, and therefore she just needs to draw 2 more. So let's say she draws out 3 blue pairs, that's 6 earrings, and she just has to draw out 1 red pair, which is just the final 2 earrings. So in total, that's 8 earrings. So should she draw out 8 earrings randomly in order to achieve this? Yes, I would say that's true. So it's not going to be C or D, so remember we just try to calculate the probability, or like try to calculate the working there. Let's have a look at A and B. B says she'll have 100% chance of picking 3 red pairs and 1 blue pair if she draws 8 earrings. Well, not necessarily if it goes the other way. Okay, so it's not B and A is right because she can get more than 1 pair of each color. Yeah, she could end up with 2 and 2, or 3 pairs of 1 color.
I love his type.
Okay, hello guys and welcome back to the channel. So just a part 2 on the probability video that I uploaded the other day. I got some more comments and messages from people.
Okay, so it's 5 out of 15.
asking if I could cover some more probability questions. So I just play random kind of Jack and Eliza process. You should really, hopefully, as soon as you see a pattern recognition.
What? Oh, bro, I didn't realize 4 out of 12. I didn't realize 4 out of 12 was a third. I thought it was a quarter.
Bang, you immediately start doing application of the process. Jack make the most mistakes. So the probability of Sachin, Jack, and Eliza processing is 0.3, 0.6, 0.1. Out of every 100, Sachin makes 33 mistakes, Jack makes 16, Eliza makes 22. Okay, so that means out of the lot, Sachin does 600, Sachin does 300, Jack does 600, and Eliza does 100 because it's 0.3, 0.6, and 0.1. Out of every 100, Sachin makes 33 mistakes, so Sachin is going to make, therefore, 3 times the amount because he's got 300, which is 99. Jack makes 16, so he makes 16 lots of that, so that's going to be 96. And Eliza makes 22, so it's 22. So does Jack make the most mistakes? I would say no, and because Sachin makes the most mistakes. Okay, so once again, not too difficult questions. You have to
Choose out by complete luck. But it says processing, it doesn't say failing.
go way through it. The reason why exactly one die shows a 5 and you win £10 if both.
You pay £1 to play a game where you roll 2 dice. You win £2 if one die shows a 5. No. That's 1 out of 12. Wait, no. That's 1 out of 6 times 5 out of 6 equals 5 over 36 times 2. You can do it both ways. That's 10 over 36, so it's just not that one.
Show 5s. So out of all the possibilities, you can see that you win £2 exactly, one die shows a 5. So that's going to be all of these. Let's skip the other 5, and then all of these as well, but then skip that double 5. So that means there's 10 possibilities out of 36. So if you play this 36 times, so the chance on each roll of you getting a singular 5 is 10 over 36. But of course, you play this 36 times, and each time that happens, you win £2. So you can see these cancels, so you're going to end up with £20 from. Okay, well, you should theoretically. Okay. You win £10 if both dice show 5s. Both dice show 5s in just one instance here, which is 1 over 36 times by 36, because obviously 1 over 36 is per go, and you roll, you play it 36 times. Times that by 10, so that becomes £10. Okay, so add these two together, it becomes £30. So should you expect to be in profit? Well, I'd say you just spent £36 and you're going to win back 30, so no. Because on average you will win less than you pay to play, because the chance of getting 5 is only 1 in 6. Well, this bit's wrong anyway because it's 1 in 10, and so C is going to be the answer. Okay, so slightly different question, but once again it's just about understanding how to use the probability. To be able to tackle it. Okay? So on to the next question. So the number of red counters originally in the bag must have been at least 14 for Peter to be more likely to be correct than incorrect. So some red counters, okay, and 10 black counters are placed in the bag. The counters are drawn at one at a time without replacement. The first 3 counters drawn are all red. Peter has to predict the code of the next counter, he predicts red. So the number of counters originally in the bag must be at least 14 for Peter to be more likely to be correct than incorrect.
if it was 14, yes. It's A.
So if either is more likely to be correct than incorrect, that means you must have more red than black. And we know that none of the black are pulled out, so that means currently there is 10 black counters. How many red counters we don't know, but if it's more likely, it has to be greater. And so therefore we know we need at least 11, for example. And if he's already pulled out 3 red counters, that means originally there must have been at least 14. So this statement, I would agree. Yes. So for that reason, so we can basically only rule out, sorry, I thought that one said no. So we can only rule out D with this. So let's read the other option. So C, because reds are drawn more often, so the odds favours black being drawn next. That's not relevant. Yes, B says yes, because reds are drawn more often, so the odds favour another red being drawn. Once again, both those are not relevant. A says because 3 reds are already drawn, the chance of drawing another red is greater than 1/2. Exactly. Okay? Because if you need it to be more likely, that means they have to have more reds than blacks, and so the only way for that to happen is if you have at least 11. Okay, so I would say A is the correct answer. Okay, so just a little bit of a shorter video. I've got a slightly longer video coming out on SJT, which will be really important, and an SJT run through as well, which hopefully be useful to some of you guys who will. Hi guys and welcome back to the channel. So I hope yesterday's verbal reasoning video was helpful. So today we're moving on to number probability. So I did another QR run through this morning. So if you haven't watched that video, any of the other videos on my channel, please do go check them out. See if you can find them. Have an equal chance of winning, and I think B is going to be the answer. It's quite a nice one actually. Okay.